Welcome to this explainer. Okay, if you're an engineering manager, you know that the decisions you make on procurement and material selection, well, they're literally the backbone of keeping commercial buildings and industrial plants running. And I mean running efficiently, both operationally and thermally. Today, we're zeroing in on why perforated cable trays have become the absolute default routing solution across the industry, and more importantly, exactly how you should be specifying them to avoid some major headaches down the line. Let's get into it.
Okay, let's dive into this. Our tactical roadmap for today covers 4 core areas. First, the thermal management advantage. Second, material selection by environment. Third, the procurement checklist. And finally, standards validation.
Kicking things off with Section 1, the thermal management advantage. And we're looking at a fascinating case study out of Guangzhou.
So as an engineering manager, you already know that theoretical performance on a spec sheet is one thing, right? But real-world impact, that is everything. Now, traditional solid-bottom trays, sure, they support heavy cables just fine. But in high-power environments, they essentially act like giant ovens, just trapping all that heat. Perforated trays, on the other hand, use those holes not just to save a little weight, but as a completely vital engineered airflow mechanism. You know heat is your absolute worst enemy, and trapped heat, that's just a fast track to system failure.
And that brings us to a massive, totally undeniable metric, 8 to 12 degrees Celsius. By deliberately switching from a solid bottom to a perforated tray design in a Tier 3 data center in Guangzhou, engineers actually reduced cable surface temperatures by up to 12 degrees. Now, in the data center world, that is a monumental drop. No exaggeration. That translates directly to an extended cable lifespan, drastically lower active cooling costs, and honestly, almost zero risk of thermal degradation. It's just a perfect example of how one foundational design choice totally transforms your bottom line.
Moving right along to Section 2, material selection by environment and how we craft those strategic specifications.
So, how exactly do we sustain those amazing thermal results across wildly different site conditions? Well, we map it out. Think of this as your ultimate engineering manager's cheat sheet. We are evaluating 4 core materials across distinct project environments. For commercial buildings, pre-galvanized steel and hot-dip galvanized are going to be your totally reliable, everyday workhorses. But what if you manage a pharma plant that requires constant chemical washdowns? In that case, 316L stainless steel becomes completely non-negotiable. And for highly corrosive manufacturing setups, that is exactly where you must deploy fiberglass reinforced plastic, or FRP. Matching these specific materials to your exact environmental demands, that's your first line of defense against infrastructure failure.
Which leads us perfectly into Section 3, the procurement checklist, focusing on execution and, crucially, risk mitigation.
Okay, so we have this brilliant material strategy, right? But how do we actually execute it? The answer is a strict pre-order checklist. For an engineering manager, this isn't just paperwork. It's a mandatory tool designed specifically to prevent on-site failures. You absolutely must verify the exact load rating, so those trays don't just buckle under heavy cabling. And you have to strictly match the material to the environmental risks we literally just talked about. Look, skipping these steps means deliveries arrive wrong, your timelines completely derail, and you end up facing the absolute nightmare of costly on-site installation failures. Nobody wants that.
All right, wrapping up our core topics with Section 4, standards validation, all about ensuring quality and compliance.
Because here's the thing, successful execution relies entirely on the manufacturing partner you choose, which means compliance benchmarks are simply everything. Xinma doesn't just slap together cable tray systems, they produce intelligent cable management solutions for a seriously wide array of sectors. And their strict adherence to global benchmarks, like IEC 6537 and NEMA VE1, well, that is exactly how you, as an engineering manager, can validate that the system is going to safely handle extreme loads without failing. It gives you that ultimate peace of mind.
Which brings us to a final, kind of provocative thought for you to take back to your engineering teams. Is your current cable tray specification actually helping, or is it hurting your facility's thermal efficiency? Think back to that massive 12-degree temperature reduction from our case study earlier. It's huge, right? Every single component choice is ultimately a performance choice. So audit your current specifications, validate those materials, and please ensure your procurement checklists are completely airtight. Thanks so much for joining me for this explainer, and keep engineering for efficiency.